Okay, I believe we are live. So, hello everyone. Welcome to the DevSecCon Greece chapter meetup. My name is Randall. If you have been to one of these before, you might be wondering where is Spiros, the normal chapter leader of DevSecCon Greece, and why is this weirdo here in his place? And I just wanted to clarify one thing, which is I am filling in. So I actually lead the DevSecCon Bay Area chapter in San Francisco, California, which is where I am right now. It is early in the morning, and we are just sort of waking up here. I wish I was in Greece, but maybe one of these days. But anyways, you're gonna have to be stuck with me for the day. So I will be your interim host. Now, if you've never been to a DevSecCon meetup before, I just want to give you a really quick explanation of, first of all, what DevSecCon is, and secondly, why it's really awesome and you're hopefully going to really enjoy this. But DevSecCon is a community organization. It exists all around the world in, I believe, 15 different countries at the moment and growing. There's almost 20 chapters that take place all around the world, including this one, where people meet up and give interesting talks focused on security, development, and the intersection of development and security. And it's a community organized thing. There's tons of people that participate in it. There's also a great Discord group where you can join and, chat with other people, make friends, go to other events and things like that. And yeah, thank you so much for coming. So today we have a couple really great speakers for you. We have Matina and Wolfgang, who I will introduce in a moment. But today they're going to be talking about key management as a superpower. So Matina works at Accenture. She's super amazing. As a matter of fact, let me bring her onto the stream right now. Welcome, Matina. Thank you for being here.
Hi, everyone. It's my pleasure.
So maybe before we begin, you could tell us a little bit about what you work on at Accenture and how you came to be here today.
Okay. I work as a security associate manager at Accenture. We undertake security solutions in general related to firewalls, key management, identity and access management, secure software development lifecycle. And I am in the security industry for a little bit longer than 13 years. So it's a lot for me. And I love to talk about security, and that's the main reason why I'm here today.
Amazing. Now, I'm going to bring in your co-presenter, Wolfgang, for a moment here as well. So welcome, Wolfgang. Thank you for joining us.
Hello, thanks.
Now, I know the two of you are going to be giving this presentation. Matina, maybe you could talk a little bit about Wolfgang and give him a proper intro as well.
Yes, of course. Well, today we're going to talk about key management as a superpower, and that means that all these abbreviations that are coming, that software as a service and infrastructure as a service and platform as a something that's very, very trendy right now. Well, key management is something, if you have a key management system, then you're supposed to have superpowers in order to achieve encryption at all levels and control your keys. So that's what we're going to talk about today. And I will be showcasing Fortanix DSM, Data Security Manager, which is a key management system that offers all these functionalities that we want. And the representative from Fortanix is Wolfgang, who will be showing us a use case related to Fortanix DSM.
Amazing. Well, Matina, I'm going to let you kick things off. And with that, Wolfgang and I are going to disappear into the background. And thank you again. And by the way, everyone, please feel free to drop comments into the live stream or into Discord. If you do comment on the live stream, I will relay your questions to the host when she gets to the question portion. So feel free to ask questions and get engaged. And with that, I will leave you to it.
So, hi everyone again. The speech today is entitled Key Management as a Superpower. And I am Matina Tsavli. As I said, I work for Accenture and I love to talk about security. I would also like to mention here that I am in the organizing committee of Open Conference. It is an IT tech conference that is held annually. And this year it's going to be held in Athens, the 2nd and 3rd of November, with both physical and remote attendance. So at the end of this presentation, I would like to offer 2 free tickets and 10 tickets with 20% discount for everyone that wants to join. Okay, you can find me at LinkedIn. My name is Matina Tsavli. You will find me there. So let's get started. What's the first question I need to ask myself when I talk about data? There are numerous data outside in the wild, and each organization has to protect this data. In order to protect this data, we have to distinct which kind of data they are, if they hold sensitive information, if they're stored, if they are at rest, as we say, or if they are unzipped. If we identify all this data, then we can find the proper solution. What is the proper solution? Well, the proper solution is easy to say but difficult to implement. It's called encryption. And there are numerous difficult ways to encrypt things, and there are numerous difficult things to encrypt. Oh, sorry. Let me go back a bit here. Okay. So what kind of levers for encryption we have? For example, we have to secure websites. We have to secure email communications. We have to secure private and sensitive data of an organization, of the employees. And for all of that, we need thousands of encryption keys within the organization. And if you understand it as a one-man job, then you're mistaken. No man can or woman can undertake this task alone. We're talking about seriously a very vast number of data to be encrypted, and of course a very large number of encryption keys needed. And now let's see, why is the security of each key important? Well, you need to have proper management policies in place, key management policies, in order to secure the keys that you have. This is a quotation coming from NIST. And NIST says that you can imagine your data as they are on a safe. If the combination of the safe is known to the outsiders, to the intruders, then the stronger safe cannot provide protection to you. So what's the important thing about this is to have strong algorithms and not have unauthorized access to these keys. They need to be adequately protected. And why does strong encryption key management matter? Well, it's very, very important. Well, there are many reasons why. You can see it's for more efficient key distribution, for greater control of your keys, less back and forth for your employees and customers and ID department, in order to reduce costs due to automation, in order to mitigate downtime, and in order to reduce data loss. Now, why do I need to protect these keys? This is also a quotation coming from NIST. And it says that security is very, very important, and it correlates to the strength of the key. You need to have secret and private keys protected against unauthorized access. Now let's talk a bit about the best practices that we need to have in all key management systems. At first, you need to centralize your encryption key management systems. I know that right now there are numerous of key systems available outside, meaning that each cloud provider offers their own key management service. Azure provides Vault, Amazon Web Services have their own, Google Cloud have their own. But what's the important thing about this? The importance here is that you don't have the control of your keys if you have them there. And you might have numerous applications that do not support these cloud providers, or they need to have their own vaults. What do you do in this case? Well, the best solution is to have a unified key management system that correlates and integrates with all the rest, so that you and only you have control of your organization keys and not the vendor. The second best practice is to use automation to your advantage. We understand that if you have a key management system, you want to do all the life cycle of the keys yourself, meaning you need to generate the key, to activate the key, to revoke the key, to issue new keys. For all of this, you need to support automation. If you support automation, your life will be very, very easier. Third and very important best practice, to centralize user roles. As we said before, unauthorized access must be prevented because there might be malicious intruders even inside an organization. So for that reason, you need to have specific roles in the organization, and only the roles with the adequate permissions can access this resource. The fourth important best practice is to support multiple encryption standards. Right now, there are numerous applications right there, and each and one of them supports different kind of encryption algorithms. These algorithms must be supported by the key management system that you plan to integrate. It's the most important thing, because I know the standards according to NIST say that you need to have ICE or RSA. Important role also play the attributes of these algorithms. How many bits? 128 for IS or 256? Or for RSA, 2048, or which padding policy? It is very important that you support all of these algorithms along with their attributes to the key management system. And the last and very, very important best practice, support auditing. The most important thing inside a security incident is to identify how it started. So you need to have adequate logging and find out where this started, from which IP, from which actor, what time exactly, what does the log contain, which data were accessed. These are mandatory requirements to have proper logging in place. And now, let's see the key management offered by Fortanix. This product is called DSM Data Security Manager. And as you will see here in the slides, it supports many use cases. It can be an HSM as a service. It supports bring your own key and bring your own KMS, supports key lifecycle management, supports encryption, tokenization, and logging and auditing. And of course, integrates with many technologies, Internet of Things, many databases, software as a service, many third-party tools, and custom applications. Now let's see the available DSM solutions. It is offered as a physical server that you can see here in the first image, which is FIPS 140-2 level 3 compliant. It is offered as a cloud server, and it is offered as a software as a service. It integrates with Azure, with Amazon Web Services, with Google Cloud, and with software as a service, and has solutions available for both on-prem and private clouds, and legacy for FIPS compliance, as we said before. Let's see a bit about the architecture of Fortanix DSM. It is an Ubuntu server. It can be on top of a hypervisor if we're talking about cloud instances, and it runs Kubernetes and Docker services within it. On top, there are some pods that are running Cassandra, which is the database, Nginx for the load balancing, and the rest of the pods are related to the crypto operations, related to management operations, crypto operations, and key management operations. It's completely containerized, it supports high availability, it supports automated backups and logging, of course. Let's see now a few of the use cases that it supports. It supports symmetric cryptography. You remember symmetric cryptography means that with the same key you can do encrypt and decrypt of the ciphertext. It supports asymmetric cryptography, meaning that you have a public and a private key, the one used for encryption and the other used for decryption. Supports tokenization. For example, a credit card may be encrypted in a way that it resembles a credit card number, but it's gibberish. It's information that you cannot make what was the initial data from it. And it also supports masking. When you replace some of the actual some of the original characters of the ciphertext with asterisks. This means tokenization. It also supports databases. This is not an exhaustive list. It supports numerous databases, but these are some of samples that I just took for the needs of this presentation. It supports secret management, all the life cycle, from key generation, pre-activation, activation, expiration, escrow, and destruction. It can also serve as a hardware security model, which is a root of trust, and as we said, it's compliant with FIPS. It supports bring your own key and bring your own KMS use cases with Azure, Oracle Cloud, Amazon Web Services, and Google Cloud. And it also supports plugins. Plugins are custom user developer code, and they can run inside the trust boundary of the server, and they have access to the REST APIs of the DSM. This is the UI of DSM Fortanix. You will see an initial screen. This is the dashboard. It can show how many security objects we have, how many tenants, how many applications we have, and it has two tabs. The System Administration tab, where we can do administrative tasks, and the Account Administration tab, when we can do things related to the account. Each account has groups, applications, security objects, plugin, tasks, audit logging, and settings. Let's see a few things about the objects of DSM. The objects can be, at first, on the highest level, we have an account. It's also called a tenant. It may distinct the functionalities. It may be a different team, it may be a different organization, a different service. And then we have the groups. Inside the groups, we distinct how many security objects and how many applications will belong in each group. Then we have the applications, which are mainly responsible for the authentication. Then we have the security objects. These are the actual encryption keys or secrets. We have users and we have policies. And all of these objects are mainly referred in the DSM using their UUIDs. As we said, we have accounts that are called tenants. Here you will see a snapshot of some tenants that can be created. As we said, this can be different companies, division of companies, teams, clients, environments, anything you want. And objects within them are exclusive to the account. No other account can have access to the objects of the other account. Users can be invited also. And how users can be invited. You can have single sign-on with SAML, with OAuth2, and with LDAP integration. And they also support logging through Google Stack Driver, through Splunk, and generic syslog. They also support crypto policies. These are the policies that can be created in order to define which kind of algorithms for encryption keys will be used, and quorum policies. Mainly related to administrative tasks. For example, if I want to delete a key, to make a quorum policy that this key, in order to be deleted, you need at least 2 or 3 approvers in order to perform the action. Then you have the groups. The groups are the top-level objects within the account. Items inside the group are equal and can be exchanged. For example, if I have an application within a group and 2 security objects, the application can have access to both security objects of the application. The security objects are owned by the group, and the groups can map to external roles, as we said before, for example, LDAP. So you can configure LDAP and have access to the specific group. And each group can have multiple applications. Of course, a group can also have its own quorum policy, as we said before, to provide access and to protect security objects within the group. Then we have the applications, pseudo entities that can be defined in order to do authentication. And authentication can be supported either with API keys, either with certificates, either with JSON web tokens, and more. And the protocols that are supported are REST API, PKCS11, KMIP, CNG. And these are the applications. Each application may have permissions specifically related to the application. For example, here you see a snapshot of the existing applications that are granted for this. And we also may have the export. This means that this application has the permission to export the security keys, provide granular control, and can generate and manage new or existing security objects within the same group. Now, what are the security objects? The actual secrets. They can be it can be a key, it can be a certificate, it can be a secret, or it can be a tokenization policy. Each security object can be either imported or generated locally in DSM, and they have specific key operations assigned to them. And they can be used through applications, meaning that the application will be used to do the authorization, and then the security object can be manipulated. And at last, we have the audit logs. The audit logs, as we said, are some of the most important parts of the architecture of the key management system. And here we support administrative logs, crypto operation logs, and authentication logs. Here you see a snapshot of the logs. They mention the actor, the IP, the type of the log, the time of the log, everything. And they can be either forwarded to CM, any CM that the company might have, the organization may have, either with Splunk or syslog. And now let's see some important information about Fortanix DSM. More than 89 millions of keys can be added in a single node. More than 1,800 requests per second per node can be supported, and that's a lot of requests. And it also offers 100% uptime for a multi-node cluster. It doesn't do any disruptions, not even any configuration, not even any during software upgrades, because it supports rolling upgrades, etc. And it's very, very important. And now it's time to see a small demo for encryption and decryption of a security object. At first, we will use an application in order for the authentication part. In the specific example, we will use the API key, which can be found in this screen as you see in the presentation. So we take the API key of the application that we have created, and we will use Postman to do the REST API calls. The endpoint that will be used is this, called using the key ID and the encrypt function. The method is post, and in the payload we need to define the algorithm, the mode, and the plaintext encoded in base64. And this is the payload. Okay, 1 second. Why? Okay, this is the payload in base64. The example in Postman is like this. You go to Authorization tab, you mention that you need basic authentication, and you use as a username the UUID of the application, and for the password, the part of the API key. If you see the API key is the UUID and the password in base64. So these are the two that you're going to use. And next, on the next slide, we need to change the body of the request and add the payload that we said before, algorithm, mode, and the plaintext. We send this, we press to send, and we receive a response, okay? And it gives us in the response the key ID, the ciphertext, and the initialization vector. This will be needed for the reverse process in order to gain the plaintext from the ciphertext in the next slide. So now we have successfully encrypted and we hold the plain text. Let's do also a decryption. The endpoint that we plan to use is called decrypt. The method is post, and we will see that we will use the mode, the ciphertext, and the initialization vector in the payload. This is the payload, this is the ciphertext, this is in base 64 encoded again. And on the top of the screen, we keep the authorization tab the same as before, and we update the body with the payload that we said before. We click on send, and this is the response we get. This is the response, we get the plain text, which is base 64 of the initial value. Okay, and now it's time for Wolfgang to take over and talk to us about this use case of Fortanix DSM.
Thank you very much, Matina. That was great. Okay, so the next topic, it's cloud data control. So this is a very, very hot topic at the moment as more and more companies are moving to the cloud. And when you do that, I mean, it's super easy, it's super cheap, but you're losing control of your data. And what do you do against that? So there might be an attack and there's very little that you can do. The solution to that is to encrypt your data in the cloud. And for that, you will need a key. You will need a key management system. And the cloud providers do offer here something, but they are proprietary. It's different for every cloud service provider. You still lose the provenance of your keys. And in general, it's just a bad practice to have your data, your encrypted data, next to the encryption key. I mean, it's like putting your key to your door under the footmat of your front door. So that's pretty much the same. So we need to do something else to achieve GDPR and Schrems 2 compliance. So next slide, please. There are two main approaches here, or concepts that I would like to explain. First, there is the bring your own key, which is BYOK. And then second, there's hold your own key, which is HYOK. Let's talk about bring your own key first. So that's the part on the left side. You see there is in the middle, there's the Fortanix DSM, and it's creating here a master key, which is green. You see this green key. And this is pushed along with the arrow to the cloud. And then you've got the green key there as well. And applications inside of the cloud can use this key to do some stuff. So we're using here a key management API, and with that we can send keys to the cloud. That ticks some boxes of your concerns, but not all of them. You're still having the key next to your encrypted data in the cloud, so it's actually a sort of a false security. We have to do something else. And the better approach is the right side. So we go for hold your own key. Here again, we are generating the key inside of the DSM, Data Security Manager of Fortanix. And then we are not pushing it to the cloud. Instead, we just have a virtual key in the cloud. You see the key is not green, it's opaque in the cloud. And applications wanting to use this key, they will reach out to the Data Security Manager, and the encryption is done inside of the Data Security Manager. It's not happening inside of the cloud, and therefore the key is never exposed to the cloud. This approach is much more secure. Okay, I would like to give you a small demo on that. How do we do this? So I would like to share my screen. Thank you very much. So this is my screen. What I've prepared here is a small or short demo on BigQuery from Google. So you see here my table. I've got here a table. And this is using for the information is encrypted, and it's using a customer managed key, and the name is GCP EKM demo. That's the name of the key. This key is inside of my key ring. So I have this key here as well. But the protection level here is external via internet. So the key is actually not inside of GCP. It is external. And where is it exactly? So we go to the Fortanix Data Security Manager. It is in this key management system. You see here, I've got the key, and it's doing some encryption and decryption operations. So let's have a look at the table again, and we can execute here a short select statement. I just run this, and you see the data is provided. We have it here. Oh, it's a little bit slow. Don't know what happened there. Okay, we have got here a couple of persons inside of this query, and we got the result back. But now you consider you see an attack on your data. You want to do something about it. So you have to lock your data. No one is supposed to get access to your data. How do you do this? You're going to Fortanix, and you just say, okay, I'm disabling my key. That's all that I have to do. Disable the key. Going back to the query, I execute the query again. And then you see there is no access to the data. That can't be accessed anymore. Permission denied when accessing the key. Then after a while, you see that the attack is over. You have secured everything. All is going fine. You want to continue with the operation. What do you need to do? You just enable the key again. We can also see this here in the log. So we just enabled the log, and we also see that it did some decryption operation. And we go back, we execute, and we see that the data can be decrypted again. It is again there. If we go back to Fortanix, then we again see that the decryption took place. We can also see in the audit log what happened in the past. So first of all, we were decrypting keys, then we were disabling the keys, and then we said, no, we don't give access to the key. And then we enabled the key, and then we can decrypt the data again. So that's it from my side. Back to you.
Thank you very much, Wolfgang. Okay. Let me go now to the next slide. So, any questions?
Hello again.
Hello.
I have a quick question for the two of you. And Wolfgang, I'm going to go ahead and bring you back onto the stream here for the question segment. But first of all, thank you both for the presentation. I learned a lot. I thought I might just ask a couple personal questions I had because I had not heard of Fortanix before this. I'm probably pronouncing that wrong, by the way. I apologize. But I've done a lot of work with Amazon KMS before for doing, in particular, like symmetric encryption for data. And when I've used tools like Amazon KMS in the past, it was predominantly that like you had some sensitive file that you wanted to store in a place like an Amazon S3 bucket or something like that. And you wanted to use like envelope encryption so that you could not really have to worry about the keys so much and sort of have everything packaged in one nice place, but be able to decrypt it whenever. And as you were going through the presentation showing, I think in the first bit there, all the ridiculous amount of customizations you can do to choosing even like the amount of bits that you're going to use in the ciphers and all that. I guess my question is, Fortanix looks a lot more customizable than the things you get out of KMS directly. Would you say that's a fair assessment? Like if you're trying to decide between using KMS natively or a tool like this, or what do you think the ideal use case is?
Well, it is a best practice to centralize your key management operations, and that means that do not depend on the vendor. It's better for your organization to have the control of your keys yourselves. Okay, I know you understand that. I can understand that there are many solutions offered in good prices right there in Amazon, in Azure Vault. I understand all of this, but the vendors, hold your keys, and you need to have a solution natively in your environment. That's my personal opinion on that. And it offers customization, and it's a very good solution. And that's why we're showcasing it right now in order to be known to the public.
Is the way that it manages the keys, is Fortanix using its own hardware security modules to store keys, or is it purely software based, I guess, on that side?
It can be offered as a hardware security module. It can offer a physical appliance.
Got it.
You can also just use it install it on your local system, or use just the Azure or AWS Marketplace and get it installed there. Then you have got it on software level. So we are very flexible. I would like to add a few things to your previous questions, as you asked for the flexibility of our solution. So we've got something like 115 integrations of different other software packages. And if you want to do something else with your key management solution, like transparent data encryption for Oracle, Postgres, MariaDB, or Kubernetes secrets injections, VMware encryption, vSAN encryption. So there's so much Snowflake, there's so much that you can do, and it's all supported out of the box.
Got it. And okay, I have a final question that you all made me think about as we're talking through this. But one of the things I'd done in the past, so I do a lot of Python software development myself, and I was using the Amazon encryption SDKs for Python, which were essentially like wrappers around what KMS basically will do. So like use envelope encryption, you'd like pass in a file, it would like, go and create a data key, encrypt the file, and then spit out like a digest with everything in there. Or an encrypted message, excuse me. I don't know why I'm saying digest. But anyways, what does the developer experience, I guess, look like for this? So you were sort of demoing things like taking a look at things in a database and all that, which makes a ton of sense. What are the like SDK level integrations look like? If you wouldn't mind talking about that for a second.
Yeah, so in general, we have got ready integrations already that you can use, and they're just there. But we also have, of course, customers that say, I want to develop something by myself. And there we have different APIs that you can use. Python is one of them. Then we've got JCE, PKSys11. Well, we've got a REST interface, a very rich REST interface that you can use. I believe if you want to do something by yourself, that's probably the best way to go for the REST, because it's just so widely usable. I mean, you can use it from any language. And the documentation for that is online. So you just go to support.fortanix.com. You have a look for the integration that you're interested in, and then you get everything that you need to go.
Awesome. Well, thank you both so much. Really appreciate it. It looks like if you have any questions, hit up Matina afterwards. She has her info on the screen there, so be sure to do that. Anything the two of you would like to share before heading out today?
Yes, I would like to say that for the people that are actually attending this conference, I would like to give away some tickets for the upcoming Open Conference. So I'd like to have a small, quick contest. So the first 12 that will send me a message on LinkedIn and tell me which type of ticket they want, remote or physical, I will be able to give away 2 free tickets, and the rest of 10 with 20% discount. And
when is that conference taking place?
It's taking place on the 2nd and 3rd of December 2022 in Athens International Megaron. And we expect many exciting speeches to take place there. And I know DevSecCon is collaborating with us for that purpose. And if you want, you're also invited.
Amazing. Well, thank you so much. That's super generous. So everyone, just to recap, hit Matina up on LinkedIn and ask for either a physical or virtual ticket, and she will hook it up, which is extremely generous. So thank you. Awesome. Well, thank you both for being here. Amazing presentation. Really appreciate it. And thank you to all of the listeners and watchers online right now. This recording will be posted on the YouTube channel, so be sure to check back to the DevSecCon YouTube channel in a couple days, and you should see it there. And thank you all for coming. We'll see you next time, and take care, everyone. Bye.
Thank you.
Thank
Have a good
you.
time. Bye.
Bye.